Okay, so today we're going to start with functional notation and applications. And before that, we're going to prepare for that. So we're starting with page 79. And the first page, the first few questions, the first 6 questions, it says evaluate the expression. So I'm just going to do one of those or 2 of those. How you evaluate expression? They give you expression and they give you value for the letter, for the variable, x, y, t, whatever it is. So let's pick one of those. Let's pick number 2. I'm going to do number 2, and then I'm going to do one fraction. So number 2, I pick number 2 because you have the negative in front. So in number 2, I need to replace t with -4. So what that means, I have negative, and then I'm going to put t plus 10. Always when you plug it in something, make sure you put parentheses on the place where you're going to plug it in. And the best way is just copy the expression, and whatever you have, tx, the letter, the variable, put the parentheses, and then after that you plug it in. -4 is the value of the t. And then we're going to simplify. How you simplify? We're going to follow the order of operations. So negative and negative is going to give me 2 negative next to each other, give me +4, and then plus 10. And when I add just these 2 numbers, it's going to give me the answer. It's 14. Okay? Everybody understand that?
Yes, ma'am.
Okay, then I'm going to do also number 4. It's interesting. We have fractions. So I'm going to do number 4 also. So number 4, we have this, we're going to do the same way. We have -3/4. I'm going to put my x here, plus 1/8. And the value for the x is 5/4. And then we're going to simplify following the order of operations. So what is the order of operations? We're going to multiply, and then you're going to add or subtract. So we're going to multiply first here, 3/4 and 5/4. Because you're multiplying, you can just see if you can cancel up and down something. In this case, 3 and 4 doesn't cancel, and 5 also. So I'm just going to multiply straight across. So I have negative 3 times 5 is -15 over 4 times 4 is 16 plus 1/8. Now, because the denominator is 16 for the one we just get, I'm going to multiply 1/8 by 2 up and down so I can have the same denominator. So I'm multiplying by 2 up and down, and that will give me 2/16, which is the same like 1/8. It's the same fraction, we just make the same denominator with the other fraction. So that's how you add them. And then you're going to add -15 plus 2 is what? -13/16. And then check if you can reduce. In this case, you can reduce. So that's my answer, -13/16. So that's how you evaluate expressions. You just plug it in, the number given for the variable, and then simplify. Okay? We're going to finish this in groups a little bit later. Now, the next one is B, the part B, where we're talking about, it's asking us to solve the equation. Now, the difference between solving equation and evaluating expression is something where you plug it in and simplify. When you have equation, you have 2 sides. You have something equals something else. You have 2 sides. And you're solving it when you get x or t or whatever variable you have by itself. And in order to get that, you need to move x's in one side, numbers in the other side, and then after that, you're going to divide by the number in front of x or t, whatever is the letter. Okay, so that's the step to solving equation. It's a different process. So how you do that? Let's do, I'm going to do 8 and 10. That looks more complicated, right? Or you can pick one. Which one you want me to do?
Definitely 10.
Okay,
Yeah.
let's do 8 and 10 because of this negative. So let's do 8 and 10. Yes, so we're going to do that. Now, I want to get t by itself. So first I'm going to move 10 in the other side. When I subtract 10 in both sides, I'm going to move it over. You're moving side to side when you do opposite. 10 minus 10 is 0. So I have negative t equals, when I add negative 4 and negative 10 is negative 14. And then I need to get t by itself. What is in front of t? I have negative invisible 1. And then in order to get t by itself, I'm going to divide by the same number in front of t. So I'm dividing by negative 1. Why are you doing that? Because negative 1 divided by negative 1 is positive 1. That's what you want to get. You want to get t equals. And again, in other side, 2 negative give you positive. 14 over 1 is just 14. So this is the solution of my equation. T is equal 14. So in the first part A, where we have to evaluate, they give me the value for the x or for the t. In this part here, part B, they give me the equation and I have to find what is t or what is x. Make sense? It's a different process. Okay, so let's do number 10. Everybody wanted to do number 10. So for number 10, we have equation where we have fractions. So probably the best way to do that is just get rid of all the fractions. And how you do that? You multiply by denominator. Now we have denominator 4 and denominator 8. So which number you're going to multiply by? I'm going to multiply by, that's right, you're going to multiply by number divisible by 4 and divisible also by 8, and that's 8. So I'm going to multiply both sides of this equation times 8. And I'm going to rewrite it so you can see step by step. So I multiplied each term by 8. So it's going to be negative 3 over 4x. And I'm multiplying also by 8. Plus 1 over 8. And multiplying by 8 equals 5 over 4 multiplying by 8. Multiplying each of those terms by 8. And when I do that, what's happened? 8 divided by 4 is 2. 8 and 8 cancel. And 8 divided by 4 is another 2. And then you're going to write down what is left and solve it. So we have negative 3 times 2 is negative 6x. I have that x there, right? Don't forget the x. And then we have plus 8 and 8 cancel. So I have 1 left equals 5 times 2 is 10. And then we're going to subtract 1 in both sides to get t by itself. So I have negative 6x equals 9. And then we're going to just divide by the number in front of x always, negative 6. So give me 1x equals, now here you can reduce, you can divide by 3 up and down. So we're going to get x equals negative 3 over 2. So that's how you solve this type of equations. Okay, everybody good so far?
Yes, ma'am.
Then you're going to go to the next part, C. And here we have few word problems. So let's go over that. I'm just going to pick one. So identify the independent quantity, the dependent quantity, and the rate. Okay, so what that means, dependent and independent. So dependent is like X. I'm sorry, dependent is Y, independent is X. So one of those is it's the original one. I mean, the one it's changing based on the other one. So you have to find what is the connection between those two quantities. Okay, so let's read one or two of those. So let's see which one you want to do first. 11, 12, 13, 14, and 15. So 11 to 14, which one you want to do? 14, okay. So let's do 14. Joe has a part-time job caring for and walking dogs. He estimates that his annual insurance is $420, and on average, he spent $450 on gasoline per visit, sorry. Okay, so which one is dependent, which one is independent? Any ideas here? Independent is something, it's X. So independent is X. So what is independent?
I guess the $4.50.
Per visit, right?
Mm-hmm.
Number of visits, yes, that's gonna be the rate. 450 is the rate per visit. So the visit is the one is gonna, the number of visits is gonna affect his, how much he's gonna get, right? So the independent is X, which is the number of visits. How many visits he's gonna make. And the rate is $450 per visit on gas. So what else they're asking? What is dependent variable?
Mm.
The income depends on the visit, right?
Yeah.
Yes, everybody see that? So dependent usually is the Y. I'm gonna put X and Y so it kind of help you out. And the dependent is the income, right? So think about if they ask you to do income, because this is his job, right? So he's spending for $420. And also this is how much he spent per visit. So how you gonna calculate that? Actually, this is all his, this is not income actually. This is how much he's gonna spend, right? So this is his cost, right? For his job. I'm gonna put cost. How much is gonna cost him, okay? Because we don't know how much he's charged, how much is the revenue, how much he's gonna get if he walk the dogs, right? Or carry for the dogs. We don't have that information. So the cost is the dependent variable here because his cost is he's paying for insurance and also he's paying for gas for visit. That's the expenses, okay? So the cost is the dependent variable and independent is how many visits he's gonna make. Now here we have fixed cost and variable cost. So the fixed cost is gonna be the $420 and the variable, which is the rate. $450. Why is variable? Because depends how many visits he's gonna make. Make sense? So that's what they're asking you here to do. Just write what is the dependent, what is the independent, and also what is the rate. That's what they're asking, right? Okay, you want to do one more?
Yeah.
Which one?
Just to be sure.
Yes. Which one?
Maybe 16 if that's cool with everybody.
Yes, 16, let's do 16. Okay, in 1990, Americans ate out restaurants an average of 143 times. By the year 2000, this has reached 170 meals out. Okay, so what is given?
Hmm.
The average mu, right? So what you have in 1990, 143 times, and in 2000, 170 times. Okay, so which one is dependent, which one is independent? What is this here in front?
Is 143 independent?
143 is actually dependent because that's the
Oh,
how many times they're eating depends in
okay.
which year you are.
Gotcha.
Okay, so the year is independent, is the X, and how many times a year Americans are eating out is the dependent, because that depends which year you are. Okay, makes sense?
That makes sense. Yeah, it
Yeah.
does.
So always think about what is X, how they're related. Okay,
Mhm.
and from here
And
you
we
can,
would just, oh,
yeah,
I'm sorry.
yeah, go
Um,
ahead.
so the answer would just be like you would label the years and then put like the year is the X, which is the independent, and then the times is the dependent Y, correct?
Yes, that's correct. Now here they don't give you the rate. They don't give you the rate, but you can calculate. We don't know if it's linear though. If you know if it's linear, you can find the slope, which is the rate of change, like how many times it's increasing every year, right? We can calculate that, but it's not given. So the rate is not given here. But you can, if it's linear, it doesn't say it's linear though. But if it says it's linear, relation between the year and the times going out, then you can find the slope. But in this case, it's not given the rate. Make sense?
Yeah, it makes a lot more sense now.
Okay, so we're gonna discuss the other questions in groups. We're gonna figure it out and then you can discuss in the end of the class, okay? Let's see, the next one is page 81. We have function and functional notation. So first, what is a function? Function is a relation. A relation is a set of input and output, and function is the relation for which each input goes to exactly one output. So think about, you have input and output, you have X and Y. Usually that's kind of the notation. You have X is the input, output is the Y variable. And think about, you have the function, it's like a black box. You put something in it, it's gonna do something, and you're gonna give you a result, okay? Now, these are the three different ways to represent a function. You can make a table like this. So this table, give me a function. So the input is -2, the output is 4. We don't know exactly what it's doing, but you can figure it out, right? So this is X, this is Y. You have it like in table like this, okay? Another way of representing a function is if they give you the graph. So you graph X and Y in the X and Y coordinate system. You know, this is X, this is Y, right? And you can just graph it and you get your graph. And then the rule, which is also like a formula, and the rule is the output is double the value of the input. So that means, what is the formula here? Y is equal to times X, right? This is like a formula. So each Y is doubling the X. So you have -1 times 2 is -2. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. So everybody understand the three different ways of representing function? Any questions here? Also notice that equation define a relation between the given x and y, where each output go exactly one output. So this is important. If you have one x, you have to get only one output. And then also we have a functional notation. Functional notation is f of x. So if you see f of x is the same like y. F of x is notation which tell me that the name of the function is f. Of x means you have a function. So you don't do anything with f and x. This is just notation. And remember, f of x is the same like y. Okay? And then we have here what f of 3 means. F of 3 means instead of x, you have 3. So just plug it in 3 for x into the function. And you just replace this x with 3. And you have 2 times 3 is going to give you 6. Now, if you look at the graph, this point 3 and 6 is going to be the point on the graph. X is 3, y is 6, right? This is the point on the graph. So everybody understand these different notations? Any questions? Everybody good? Okay. And here we have example. We just talk about 2x function. You have the input, the output. So in this case, they give me that y f of x or y equals 2x can represent different things. In general, like y equals 2x can have any value, but here if this f of x equals 2x represent cost and gas, the cost, so dollars and gallons. If you have something specific, like if it's application in general, then x and y has to be positive most of the time. So that means the graph is not going to be the whole straight one. It's going to start from 0, 0, because the gallons and the cost are positive numbers, right? It makes sense. So the negative numbers are excluded because x and y represent gallons and cost. Make sense? So here you have another one. Another example. Suppose you bought a car for $3,500 and you pay $50 per month for insurance. We have the variable cost, which is per month. It's the variable, and fixed is what you pay only once. And then the equation is going to be, the equation of the cost function is going to be f of x equals 50x plus 3,500. And then if you have this function given, we can fill the table, and also we can sketch the graph. So how are you doing that? Just using the equation of the function. We have x is 0, so I'm going to replace x with 0 here, and I'm going to find the y. So calculating this value is going to be 50 times 0 plus 3,500, right? So 50 times 0 is 0. So the answer here is 3,500. Then the next one, I'm going to replace x with 3. So finding when you have x is 3 is going to be 50 times 3 plus 3,500. So what is that? 150 plus 3,500. What is that? 3,650, right? Okay. Then when you have 6, x is 6, you're going to plug it in again. Hundreds. 50 times 6 is 300, right? Plus 3,500, 3,800. Okay, and then the last one is when you have x is 12. So you have 50 times 12 plus 3,500. 50 times 12 is what? 60, right? Oh, 600, sorry. So you add in 3,500 plus 600, and that's 4,100. So everybody understand how I calculate the value for the y? We have independent variable given, and finding the dependent, you just following this equation, following the equation of my function. And then we're gonna graph those. So we have x is 0, y is 3,500. So this is between 3,000 and 500, sorry, 3,500. So I have 3,000 and somewhere in the middle here. This is my first point. Then after that, I have x is 3, and then it's gonna be a little bit more, right? 360. And then 6 is gonna be 380, a little bit more, close to 4,000. And when it's 12, it's gonna be above 4,000 and stuff, 100. So when you connect it, you're gonna get the straight line. And that's the equation, that's the graph of the function, the graph of the equation. Now, keep in mind, we have x and y months and dollars, so you don't go before the y-axis, right? It have to be after. And actually, you can continue. So you can just continue here. Okay, everybody understand that? Let me just put this 12 in. Any questions? So what type of, what kind of function is that? Increasing or decreasing? Is the line going up?
It's increasing.
Good job, it's increasing, that's right. Okay, so that's how you do this one. And then function and functional notation, we have just evaluating. And then you have to find the value for each of the given functions. I mean, actually you have one function given, you have to find different value, and you have to find the corresponding point on the graph. So let's do 1, 2, 3, let's pick one. So looking at number 1, 2, 3, which one you want me to do? So this is the function we're using. So you want 1, 2, or 3?
3.
3, okay. Okay, so here for 3, okay, everybody want 3. So we need to find x, and also for each question state, are you given the input or the output? So what is given for number 3? We have given f of x equals 85. Is that y or x? What is given?
Y.
Y, good job. So this is input or output? It's the output. Y is the output, x is the input. Okay, so we have given. So how you find it? Just follow the function. We have 85 equals, you can just write 9x minus 5 equals 85. And you're going to get x by itself when you add 5 in both sides. And you get 9x equals 90. Divide both sides by 9. And we get x equals 10. So x is 10. We found x. Now, what is the corresponding point on the graph? X is 10. And what is y? 85. Everybody see that? So this is the answer for the point on the graph. And this is the finding x answer, okay? Let's do number 4. So for number 4, do we have given the input or the output value? What is given? We have given a, and a is in the place of x, so this is input or output?
Input.
Input, good job. So this is the input value given, and we need to find the output. So a is the input. So how are you going to find it? Just follow the function 9x minus 5 and plug it in, replace x with a. So it's going to be 9a minus 5. That's it. Just leave it like that. It's an expression because you have, there's no numbers. You have variable. You can't simplify this. So just leave it like that. 9a minus 5 is the value of f of a. Make sense? Next one is the same way. You have to evaluate. And number 6, which one you want me to do? 5 or 6?
5.
5?
Yeah.
Okay. Okay, so let's do 5. We have to evaluate f of 2/3. 2/3 is the x, which is the input. So I have to find what is f of 2/3. So I'm going to follow the function 9x minus 5 is the function. And in the place of x, you're going to plug it in. You're going to substitute 2/3. And then you're going to simplify. Remember, 9 is 9 over 1. So you can, when you cross multiply, you can reduce 9 and 3, divide by 3. And this gives me 3. So I have 3 times 2 is 6 minus 5 equals 1. So the y is, let me write it here, x is, the x value is 2/3. And the y value, the output is 1. So if I write the point, corresponding point on the graph, what is going to be the point?
2/3 and 1.
Comma 1. That's right. Good job. So finding the output, finding the output and that having output and input is going to help me with finding the point. Okay, everybody understand that? And number 6 the same way, you're solving it. Okay, so we got that. Let's see if you can, we'll do one more page. For the following graph, to answer the question. So we're going to use this graph. And let's do one of those questions or 2 of those. That's where you're going to stop, and then you have the homework in page 85. So let's start with, so this is the graph given, and we have to read the graph. So if you have f of number, the first 7 to 11, all these questions 7 to 11, you're just going to go to the x is given, and you're going to go to the graph and find the y coordinate of that point. So pick one from 7 to 11. 7 to 11. Which one?
7.
7. Okay, let's do that. Somebody say 11. Okay, let's do 7. So for number 7, we have to find f of 3. So 3, is it x or y if it's inside? It's x, right?
Yeah, so that's input.
That's the input, that's right. So we're gonna go to the x-axis, which is the horizontal, and the vertical is the y. And I'm gonna go to 3. And then from 3, I'm gonna go all the way to the graph. See, where's the graph? This is the point on the graph, right?
Mhm.
I'm gonna get the coordinates of that point. So what is x? X is 3. What is y?
4, positive 4.
Positive 4, that's right. So this is the corresponding point on the graph when x is 3. And they're asking me to find f of 3, which means finding what is y, the output. And in this case, it's gonna be 4. Everybody understand that? So just going to the graph, going to the whatever x they give me, and then find the y coordinate. So if it's given x, you're gonna get the y coordinate from the point. Okay? Now let's do one more. I'm gonna just pick something else which is not given. So let's see what is f of 6. They don't give me that. So let me know what is f of 6. I'm just making another question. F of 6. I'm gonna go to x is 6. I'm gonna go to the graph. And I'm gonna see what is the y coordinate for that point.
4.
It's 4. That's right. Okay, everybody understand that? So let me get you one from the negative side. So let's say we have -3 and -4 and -10. So let's take f of -6. It's not given. I'm just gonna make another one, -6. So I'm gonna go to -6 here, and I'm gonna go to the graph. Looking at this point, what are the coordinates for this point? -6 and -2, right?
Mhm.
So what is the value? -2. Okay, so
Negative
just
2.
reading the graph. You just read the graph. You don't do anything else. Just read the graph. Okay, then the next part here, number 12 to 14, they give me the y. Which one you want to do? 12 to 13 or 14? 12, 13, 14. Pick one.
Let's see. Want to do like 13, I guess.
13. Okay, let's do 13. So, so here they ask me to find x, and we have given f of x is equal 1. So 1 is actually the y, right? So we're gonna do the same. We're gonna go to the graph and see when y is 1. So let's look at the y now. We're gonna start with the y coordinate. Y is 1 right here. And then I'm gonna go to the graph and I'm gonna look at this point. And I need to see what is x there. So what is x for this point?
-3.
Yes, -3, comma 1 is the coordinate, and that's what they're asking you, -3. Everybody understand that? Yeah, that's it. Just reading the graph. So x is -3. This pretty much conclude the lecture for today. Home is in page 85. Okay, I'm gonna stop the recording. And you're gonna have this like a lecture recorded. Now I'm gonna go over, I'm gonna split in group. I'm gonna finish this, and then I'm gonna tell you what you're